This lesson is the Pythagorean Theorem. We're going to use the Pythagorean Theorem to find side lengths of right triangles and test the side lengths of any triangle with the Pythagorean Theorem to see if it is a right triangle. So the Pythagorean Theorem says that if you have a right triangle with legs A and B and hypotenuse C, remember the legs make up the right angle, and the hypotenuse is the side across from the right angle. When you have that, then a squared plus b squared equals c squared. A lot of the times you'll see this with lowercase letters instead. That a squared plus b squared equals c squared. C is the hypotenuse. It's the longest side of the triangle. It's the side across from the right angle. A and B are the legs. The legs make up the right angle. So in this example, if A is 3 and B is 4, find C. So if A is 3, B is 4, let's find C. Well, use the Pythagorean theorem. A squared plus B squared equals C squared. A is 3, B is 4, and we're looking for C. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. Now we're looking for C, not C squared. So the opposite of square is square root. So we'll square root each side. The square and the square root cancel out, leaving C. Square root of 25 is 5. So C is 5. Notice 5 is bigger than 3 and 4, and the hypotenuse is always larger than the two legs. It's the longest side of the triangle. So substitute into the Pythagorean theorem and solve. So let's try some more here. How about if A is 8, B is 15, find C. Again, remember C is the hypotenuse, it's the longest side, and it's the one that goes by itself in the Pythagorean theorem. So A squared plus B squared equals C squared. A is 8, B is 15. That's a 64 for 8 squared and a 225 for B squared, 15 squared. 64 plus 225 makes 289. And then to undo C squared, remember square root each side. Square root of C squared is C. Square root of 289 is exactly 17. So that one's a 17. Use the Pythagorean theorem. C is the hypotenuse, which is the biggest side, and it worked. 17 is bigger than 15 and 8, so it did check out pretty good there. How about if A is 7 and B is 24? Well, A squared, that's a 7 squared, plus B squared, that's a 24 squared, equals C squared. 7 squared is 49. 24 squared is 576. 49 plus 576 is 625. Then when you square root each side to undo the square, C is 25. A squared plus B squared equals C squared. A and B are the legs, C is the hypotenuse, and C is always the biggest side. Sometimes you're looking for one of the legs. Just make sure you substitute everything in properly. Here, B is 5, C is 13, find A. Well, remember, A squared plus B squared equals C squared. We don't know A, so that's still A squared. B is 5, C is 13. 5 squared is 25. 13 squared is 169. And when you're looking for one of the legs, you're going to have to do this move here. Since the 25 is over here with A squared, we'll subtract it from each side to move it over to the other side. A squared is now 144. Square root each side, and A is 12. Notice C, the hypotenuse, is still the biggest side. 13 is the biggest side. We were looking for one of the legs. So here's a few more. A squared plus B squared equals C squared. Looking for B this time. That's 64 plus B squared is 100. Subtract 64. B squared is 36. Square root each side, and B is 6. How about if A is 15 and C is 17, find B. A squared plus B squared equals C squared. 15 squared is 225. 17 squared is 289. Going to have to subtract 225 from each side. B squared is 64. Then to solve for B, undo the square with a square root, and B is 8. How about if B is 10 and C is 26, find A? Well, A squared plus B squared equals C squared. A squared plus 10 squared is 100. 26 squared is 676. Going to have to subtract 100 from each side. And then undo the square with a square root, and A is 24. Here's another one. If A is 15 and B is 20, find C. Well, A squared plus B squared equals C squared. 15 squared plus 20 squared. You could even do that in one step. Punching that in, that's a 225 plus 400 is 625 equals C squared. You can do that when both of these are on the same side of the equal sign. And then square root each side again. Square root of 625 is 25. Square root of C squared is C, so C is 25 on that one. A squared plus B squared equals C squared. That's the Pythagorean theorem. Now sometimes They'll give you three side lengths and they'll say, is it a right triangle? Well, test the Pythagorean theorem. Remember, the Pythagorean theorem says a squared plus b squared equals c squared, and c is the biggest side. If it works, then it's a right triangle. If it doesn't, then it's not. So a squared will be 6 squared, b squared is 8 squared, and c squared becomes 10 squared. 6 squared plus 8 squared is 100. 10 squared is 100. These are equal, so it works. This is a right triangle. If they ended up not being equal, then it's not a right triangle. So anytime you know it's a right triangle, use the Pythagorean theorem to find a missing side. Or if you don't know it's a right triangle and want to know if it could be, take the three side lengths, substitute them in where c is the biggest number, and see if it works with the Pythagorean theorem. If it does, then it is a right triangle, and if it doesn't, then it's not. Here's a couple more examples. We know these are right triangles. Let's find x. On this one, 13 squared plus 23 squared equals x squared. Remember, x is the hypotenuse, so it's going to go by itself. 13 squared plus 23 squared is 698. And I can square root each side. Square root of 698 is about 26.4. And the square root of x squared is x. Sometimes it's a decimal. And if it's a decimal, round to whatever they ask you to round to. Usually it's the nearest tenth. On this one, 34 is across from the right angle, so 34 is the hypotenuse. A squared plus b squared equals c squared. 34 is the one by itself here. 21 squared is 441. 34 squared is 1,156. Subtract 441. And x squared is 715. Square root each side. And x is about 26.7. Just remember when you set these up, c is the biggest number. It's the hypotenuse. Our final topic here is a Pythagorean triple. That's three whole numbers, so they have to be integers, positive integers there. No decimals, no fractions, that satisfy the equation a squared plus b squared equals c squared, where c is the biggest number. So in other words, the Pythagorean theorem has to work, and they have to be whole numbers. So let's see if these are Pythagorean triples. So can they be a right triangle, and do they form a Pythagorean triple? First, let's see if it's a right triangle. Test the Pythagorean theorem, and remember, c is the biggest side. 9 squared plus 40 squared is 41 squared. I put 41 by itself because it's the biggest number. 9 squared plus 41 squared is 1681. 41 squared is 1681. That's true, so it is a right triangle. Then, is it a Pythagorean triple? Well, the Pythagorean theorem worked, and these are all whole numbers. So it is a Pythagorean, I'll abbreviate, a Pythagorean triple. So that's a yes for both. This next one, biggest number is 29, so that's C. A squared plus b squared equals c squared. 29 is by itself. 7 squared plus 28 squared is 833. 29 squared is 841. That's not true. So this is not a right triangle. And if it's not a right triangle, there's no way it's a Pythagorean triple. So it's also not a Pythagorean triple. Even though they're integers, since it's not a right triangle, it's absolutely not a Pythagorean triple. 9/5, 12/5, and 3. Let me make a new screen here to have more room. 9/5, 12/5, and 3. Well, let's see if the Pythagorean theorem works. 3 is the biggest number, so we'll do 9/5 squared plus 12/5 squared equals 3 squared. When you square a fraction, square the numerator and square the denominator. 9 squared is 81, 5 squared is 25. In the next one, 12 squared is 144, 5 squared is 25, and 3 squared is 9. Now when you're adding fractions, you need a common denominator, which we have, so just add the numerators together. 81 plus 144, and we get 225 over 25, and that equals 9. Now, what's 225 divided by 25? And that's also a 9. So 9 equals 9. This is true, so it is a right triangle. Now, are these whole numbers? No, they're not. We have two fractions, so it is not a Pythagorean triple. Even though it is a right triangle, since we had fractions there, it can't be a Pythagorean triple. So use the Pythagorean theorem. A squared plus b squared equals c squared. C is the hypotenuse, a and b are the legs.